Hi guys, good evening. I hope you all are doing well. Please let me do in a chat that can all you hear my voice properly or not. Okay, sir. Thank you so much, Amit, for let me know that I am audible. Okay, guys. So I think most of the people has joined. So let's start the session. Okay. So before start the session, I would like to do a quick recap whatever the things we have done yesterday. Okay, so what are the things we have done yesterday we started with the introduction of. Okay, thank you, Abhishek. Okay, so yesterday we started with the introduction of the LLM, right? Then we see what is the LLM, what are the data set on which this LLM has trained, right? And then we see what are the types of the LLM, and also we see what are the purpose of developed such kind of the LLM, what are the needs of that kind of the LLM, right? And after that, we also have seen like what is the Llama index, what is the uses of the Llama index, what is framework. So Llama index is nothing but a framework. So before start the Llama index, we saw that what is framework, we understood in a good way that what is the framework, and then we learned about a Llama index, like, because it is also a framework, right? So these and a part of this we also say like uh, what is there are some terms and technology we learned about a LLM, right? Like we use something called context window, token size, right? Token limit and temperature. These are the terms we learned yesterday. So all and during while learning all these terms, what we learn, like we see like okay, this model takes the text as an input, but models, any LLM models doesn't work on that text, right? It what it does, it start like all the text going to be converted into the small chunks, right? This is called a token. So let's suppose my name is Samir Singh. So this complete sentence, my name is Samir Singh, is going to be divided into the small chunks. And these small chunks is going to be called as a node. And sorry, this small chunks is going to be called as a token. And these tokens going to be converted into the number, which is nothing but a embedding. And in Llama index, this embedding called the indexes, right? So we have seen like how this all process has done, right? And after complete this after learn this all this theoretical part, what we done, we has seen some of the practical implementation also, that how actually through the code we do all this thing, right? So this was the story, this was the quick recap which we have seen yesterday, right? So this was a whole story about the session one. So I think I have covered all the things. So now in today's session, uh, we will see the RAG principle, right? Although yesterday I have also covered a RAG principle, which is nothing but retrieval augmented generation, right? So this RAG principle, just a quick story I was telling you, but today we will see the RAG principle in depth, and also we will cover all the body parts of the Llama index, right? And today like I'll say that only the 30-minute, max to max 30-minute, we'll see the theory behind the Llama index, and whole 1.5 hour will spend on the Jupyter notebook. So this will be the story and agenda for today's session. So I hope that today's agenda and recap, everything is clear to all of you, right guys? Please do let me know in the chat so that I will start the today's session. Great. Okay, nice. Thank you everyone. So I am going to share my screen. Please do let me know once you all can see that. Okay. Yeah, so I have shared the screen. I hope you all can see that. Just a second, guys. Okay, great. So I hope you guys are, you can see a diagram on my whiteboard, right? Is my screen visible for everyone? Okay, great. Everyone can see that. Okay, fine. So let's start with the today's session, guys. So this is nothing but the I will say RAG principle, and I'll say the body part of the Llama index of the Llama index. So now let's understand it. So I hope if I'm going to explain this diagram, before explaining this diagram, I hope the whatever we have done in yesterday's practical, so this is very much clear to you, right? So we have implemented a code yesterday, so in which what we were doing it, we had three text file, let's say 1.txt something, 2.txt, and 3.txt, right? And then we loaded it using some loader, and the loader name was simple uh, directory loader, right? Simple directory loader. Then using this loader we were loading all these three files, because all these three files inside a folder, right? So in order to load this, we were using this particular library. Then we were using we were just converting all these sentences into the embedding, right, which in Llama index it is called a indexing, right? Then we were doing some query. Basically we were asking some question from this embeddings, right? Now, see here, just keep the whole process in your mind, and now let's understand this whole RAG principle. Let's understand this whole, we can say this diagram. Okay. Now, here we have the data sources, right? Now, data sources can be, it can be folder, it can be from any, it can be, we can say, uh, AWS folder, right? It can be a link, website link, right? Web link, right? It can be anything. So all the data sources we were loading it, right? So how we were loading? With the help of the data loader. See here, you can see that with the help of the data loader, and we have the different type of the data loader also. We'll see when we will do the practical. Okay. So here we were doing the using the simple directory reader, right? Simple directory reader or loader, right? With the help of this particular library, we were loading all this data, right? Now, after loading it, we can see that we had in a document or nodes. Now here, see guys, I am using a node. Now again, a question comes that what is node here? So nodes is nothing but it is the smallest part of the whole text. So suppose we have 100 lines of the paragraph. So this is the complete paragraph, right? Now, when we will divide all this complete paragraph into the smaller chunk. So let's say we are going to divide all this paragraph into the 5 chunks, right? So now the each chunk is going to be called as a node, right? So remember, guys, what we were doing, we are loading the data sources with the help of the data loaders. Then we are dividing the whole data, the whole paragraph, the whole context, the whole text into the smaller chunk, and these smaller chunk is called the node in the Llama index, right? Then when we are going to, once we will complete this operation, once we will divide all whole text into the smaller chunk, which is nothing but a load, what we were doing it with the help of the indexing method, we are going to, we are creating the embeddings of all these nodes, right? So we are doing, and the embeddings, to create the embeddings or embeddings called indexing in Llama index. I hope this is clear to you, right? So now this indexing, after perform this indexing, we are storing it into some database, which is called a vector database, right? So I am saying here it is the indexing knowledge base, right? Then we created a query engine, right? So I hope you guys remember that there's something, some variable we have created yesterday, which name was the query engine, right? Then with the help of this query engine, what we were doing it, we were asking the question, and this query engine were finding the similarity with from this index knowledge base, and it was returning the similar content, which was nothing but our answer, right? So this is the whole process yesterday we have seen, right? So till here, guys, in this first pipeline, is it any date, any confusion, any question in this first pipeline which we have just covered now? Okay, great. So let me quickly okay, repeat the notes. Sure, I will repeat it. So I'm going to repeat the whole process once again so that it will be clear for all of you, right? So see here, we had a data sources. This data sources can be anywhere. Uh, this data sources can be in the folder. These data sources can be the website link or anywhere you have the data, right? Now you will load the data with the help of the data loaders. Now for with respect to the data loaders, we have the different library also. Like we have a simple directory reader, we have PDF reader, we have read the data from the website. We have the separate library for that, right? With the help of the those library, which is called the data loader, right? With the help of this data loader, we are loading the data and whole data, right? We are going to divide into the smaller chunks. These are smaller chunks called the nodes, right? Now all the nodes we are going to convert into the number, right? Now the conversion of the text to node is called indexing, right? Or embedding, right? Embedding and indexing both are same, right? Now since now we have the vectors, right? Lot of the vectors we have, I mean we have a lot of the embeddings. Now you cannot keep all those embeddings inside the inside a variable, because just think that suppose that due to some reason your pipeline is going to be break. So this indexing takes time. Suppose you have like 5,000 pages of the book, right? And now if you are going to convert the if you are going to create the indexing of all the data, it will take time. It will take 30 to 40 minutes, or maybe sometime 1 hour it will take it, right? Totally depends on your machine specification. But let's suppose that if this whole pipeline is going to be break, so in that case, are you going to spend the whole time, I mean the whole 1 hour once again? No. So in that case, you need some space where you will store all the embeddings, right? And in order to store the embeddings or indexes, we need a database, right? And this database is called a vector database, in which we store all the embeddings, right? Now this vector database I'm saying here, it is nothing but the index knowledge base, right? Because it has all the knowledge of the custom data, right? Now we were using the retriever. Now we were creating the query engine, right? Now in with the help of this query engine, we were asking the question from the LLM, right? Now whenever we are asking the question, what it was doing, it was finding the similar content from the knowledge base. And once the most similar content from this question, whatever the most similar content will be there, it will extracting it, it was retrieving it, and it was showing to us, right? So this was the whole story. Yes, Mohammad Umair. So I hope now it is clear to this complete whole, the first line is completely clear for you, right? Great, Abhishek. Fine. Any doubt, guys, in this is the, because this is the major thing, right? If you will understand it, I don't want that anyone all of you have any kind of the question in that. So right, great. So I think there are 30 people the in this class, so I would like to hear at least all of them, whether is it clear or not. So just give me the quick, if clear then write the clear, not clear then write the not clear, right? So so that I'll get the insight, like all of you are actually getting the things. Great. I think you, most of you are getting the things. See, RAG and Llama index functioning are same. Yes. See, Llama index is just a framework, right? I'm explaining you the this whole pipeline is the RAG, right? For the RAG. But I am explaining you in terms of the Llama index, right? So whether you are using the Lang chain, whether you are using the chain lead, which is the again the another framework for develop the Gen AI application, right? So whatever the framework you are going to use it, the basic architecture is not getting the change, right? It is just like that. Just suppose that you'd have to go to the US, right? So whatever the path you will take it, at the end you will have to go to the US. Your destination is not going to be changed. The path, which the route, it's totally up to you. You will have to decide which route you will have to take it, right? So similarly here also, at the end we'll have to develop the Gen AI powered application. Which framework are you going to use it? It's totally up to you. Whether you are going to use the LangChain, whether you are going to use the Llama index. Both functionality are same. I mean, the way of working will be different, but both at the end, both are going to perform the same task, right? So this whole pipeline is the RAG principle, and I'm explaining you in terms of the Llama index. I hope this is clear to you. Yes, MKS embedding and indexing both are same. I think Devashish, you are very much clear with that. Like RAG and Llama index functioning are same or not. Okay. So which other frameworks are there? See, we have LangChain, Llama Index, Chainlit. We have so many others are also there. Lots of the there, right? Just write on the Google what are the alternative of Llama Index and LangChain. You will get so many frameworks. But out of all the things, see, Llama Index and LangChain, these only two are the very famous, and they have the support also, right? Developer support. Okay, fine. Now let's move ahead. Now you can see there are three things I am doing here. One is retriever, the another is this is the first is retriever, second is node post processor, and third is response synthesizer, right? Now see, दिस इज द वेरी स्मॉल वर्क्स, इतना छोटा सा वर्क्स है, राइट? इसमें ही मैंने बता दिया, इसमें सिमिलैरिटी सर्च करा, इसमें से चीजें निकाल के दे रहा है, हमें आंसर मिल गया. बट हाउ द एक्चुअली थिंग्स आर वर्किंग इंटरनली, राइट? दिस इज द मेजर गोल. We should know it about it. So what is happening here? So whenever we are asking any question, let's say we are asking a question, what is the email id? What is email id, right? What is email id? Now power to developer then Llama. Yes, LangChain is doing great in terms of the in terms of Gen AI powered application, but it have also the support of the LLM ops. They have developed Langsmith and all, but I don't want to explain you here, right? Because most of the people who has joined this classes, they are very much beginner in that particular case, right? So let's understand first about this, Llama index. Then slowly we'll go in the depth also, right? Okay. So now let's start it. Okay. So retriever. So let's suppose that we are asking any question like what is email, right? Now this email, we will this from the index from the whole data vector database. With the help of the retrievers, it is going to find a similarity search, right? So retriever here is used for the similarity search, right? So whatever the most similar, or you can say whatever the most relevant content you will get it, you will get it with the help of the retriever. So retriever is used for similarity search, right? Now, suppose you'll get it. Let's say you have asked what is the email, and here the email is something like that, xxx@gmail.com, right? Now, right, you have, so with the help of the retriever, it will get this is the most relevant text here. Now, this whole text is go on the node post processor, right? Now, what is the work of the node processor is that, let's suppose there is some extra sentences and an extra symbol or special symbol are there. So basically it perform the text cleaning kind of the task, right? So whatever the unrelevant words or text or symbols will be in the sentence, this with the help of the node post processor, we are going to remove all those things, right? So now what happened, we ask the question, with the help of the retrievers we get the most similar or most relevant answer with for this question, right? Now that particular question, I mean that particular answer will be passed to the node post processor. Now this node post processor, what it is going to do, it is going to perform a kind of text cleaning things, right? So whatever the unnecessary things or unnecessary symbols or whatever the unrelevant things will be in the text, it is going to be remove it, right? Now we have a clean text. Now with the now this clean text we are going to get as a response with the help of the response synthesizer, right? So basically these three steps internally this index knowledge base perform, right? So what happened, now I'm going to again explain you in depth. So we have in whatever, whenever we ask a question from with the help of the query engine, the with the help of the retriever we are getting the most relevant answer, right? Now let's say that most relevant answer has some I mean unnecessary text and some special symbols are there, right? So just a second, guys. Just a second. Okay, fine. Sorry. Actually, my throat isn't good. Okay. So we got okay, let's me explain you once again. पूरी वो flow टूट गया ना. So whenever we are asking any question, the retriever is going to fetch or retriever is going to get the most similar or most relevant content from the knowledge base, right? Now this relevant content can have the unnecessary or on some special symbol which is not useful, right? So this kind of the text cleaning is going to perform by the node post processor, right? Then when after performing this text cleaning, basically once the text is passed through this node post processor things, with the help of the response synthesizer, this response synthesizer is going to show the response to us, right? So if we are asking what is the email ID and we are getting some xyz at the rate gmail.com, so this output we are getting with the help of the response synthesizer, right? And the most relevant content we are getting with the help of the retriever, and the in middle whatever the text cleaning is going to be performed, it is going to perform by the node post processor. So this is whole story behind the RAG principle with the help. So this is whole things happen internally when we are performing the RAG with the help of the Llama index. So in whole pipeline, if anyone have any kind of the confusion, please do let me know, guys, in the chat section. So this is the whole theory, right? Okay. So Umair is saying clear. Great. Okay. So do let me know in the comment, in the chat section, who doesn't clear the thing, right? Uh, it's okay, guys. If you are not getting the things, do let me know. I will clear it again, right? आई वुड लाइक टू सी द पर्सन जिसको क्लियर नहीं है, राइट? अगर हिंदी में चाहते हो तो मैं एक बार हिंदी में भी एक्सप्लेन कर दूंगा, ठीक है? यस सौम्य. Node processor just works on cleaning on text retrieved or any other task also is performed. The kind of the cleaning only it perform, right? I am waiting for 2 minutes. If any question, if you guys have it, please do let me know. Okay. Sudham, we store the embeddings in vector.db. Then how come after that we clean the text while retrieving the information? Exactly. Good question, Sudham. So see, we actually most relevant thing is something like that. We are finding we are doing the similarity search on the basically on the vectors, right? So at the end, this response synthesizer is going to convert all these things, I mean, this response is going to be sent by the you can say sent by the response synthesizer, right? But if so what it is, how exactly this similarity search is going to be happen, let me show you. Let me write a complete thing once again. What algo is used in similarity search? See, we have different algorithm. We have cosine similarity, Manhattan similarity, Euclidean distance. We perform it. So, but by default, and most of the famous algorithm, we use the cosine similarity in order to find the similarity in between the text, right? So, what is happening here? See here. See guys, whoever having a confusion, like how exactly the similarity search perform and what is the role of the post processor. So let's suppose we have a complete text. I am writing my name is, let's say my name is, I'm saying my name is Samir Singh. My email ID is xyz@gmail.com, and I am from Gorakhpur, and let's say I'm saying, and I am a senior AI engineer, right? Let's say I have written this thing, right? Now, this is the whole paragraph, let's say I have. Now, we are going to perform the chunking, right? We are going to convert it into the nodes. So now, once we will convert it into the node, what is going to be happen, right? See here. Now, whenever we are going to perform the node, uh, let's say we are going to divide it into the two part. See, we have my name is Samir Singh and email ID is xyz @ gmail.com, right? This is gonna be first chunk, right? It is gonna be the first chunk. The second chunk gonna be something like, and I am from Gorakhpur and I am a senior AI engineer, right? Let's say this is the second chunk, right? Now, when we are going to convert into the indexing, so we will have basically two kind of the two indexes, right? So we will have, see, we will have the embeddings, right? Let's say 1100, 110, whatever the embeddings we'll have with respect to this, and with respect to this also, we will have some numbers, right? Now, if you are going to ask, like, what is like, let's say if you're going to ask what is email ID, right? Now it is going to find a similarity because it is also going to be converted in some number, right? Now it is going to find a similarity since we don't have any kind of the email terms in the second thing, right? So that is why this is going to be the most similar chunk, or we can say most similar embedding with respect to this email. But in this particular embedding, we have some extra things also, right? So we need only the email ID, but do we need this? We don't need it. We don't need kind of this. We need only this part. We need only this part, right? We don't need all these things. So who will be responsible for clean all this kind of thing? We don't need it. So here node post processor is going to remove all this thing, and now response synthesizer is going to return only this email ID, right? So this is the task of the node post processor and the response synthesizer, right? So I hope this is clear for everyone, right? Am I Was I given the answer of your question, or still, guys, do you have any doubt? Great. ओके, नाइस नाइस। ठीक है। ओके, ग्रेट गाइस, फाइन। ओके, सो okay, let's move ahead. So now I am going to explain the code. So now this was a total story for today's, right? So आज का थ्योरी पार्ट खत्म। अब चलते हैं हम अपने प्रैक्टिस। अब कोड क्या क्या करेंगे। हम देखेंगे कि हमने हम एलएलएम कैसे क्रिएट करेंगे, चैट मॉडल्स देखेंगे, राइट? उसके बाद फिर हम बहुत सारी चीजें देखेंगे। आई डोंट वांट टू कंफ्यूज यू कि ये क्या होता है, ये क्या होता है। देखते हैं साथ में ही कि जब कोड करेंगे ना तो एक साथ देखते हैं, राइट? सो एंड आई एम आल्सो अज्यूमिंग दैट आई डोंट नो, मैं भी आपके साथ ही एक्सप्लोर करूंगा, राइट? सो दिस इज हाउ आई थिंक आई कैन एक्सप्लेन यू इन अ बेटर वे। Okay, so what I'm going to do, I'm going to stop the sharing, and I'll share the VS Code with all of you guys, right? So let me open that first. Mm, here's the. So I just want to know how many of you has did the practice on the same thing which we have done yesterday. Great, great guys, really, it's just very good, awesome. I'm feeling good that you guys have practiced all this thing, right? Just a small tip, guys, I want to give to all of you. Whether you know all the things, whether you are expert, but whenever you are going to learn somewhere, right, just treat yourself as that you are a little guy, you don't know anything. This is just a mantra of learning anything, which I do. Even one of most of the people who learn with me and my colleagues, my friends, everyone to like आप किसी को भी देखोगे ना, किसी भी बड़े प्रोफेसर को, किसी को भी जब वो क्लास में जाते हैं ना, दे ट्रीट देयर सेल्फ एज दैट दे आर जस्ट अ लिटिल गाय। बिकॉज एक एरोगेंट आ जाता है दिमाग में कि I know this thing. I already know this. Why should I have to focus it? I know whether you know this topic better than the next person, but maybe there will be one, two, 3 points the next person can explain to you which you don't know, right? So, but if you have such kind of the arrogant in your mind, so definitely you are going to lose. You're going to drop the opportunity to learn those three new topics which you could learn that, right? Or maybe you are going somewhere the same thing can become, right? Because in terms of the technology, I think nobody is a perfect, right? Whether the person have a 10 to 12 of years of experience. Great. Now let's start it. What? Let me share my screen. सो द जो इन्वायरमेंट हमने कल बनाया था सेम इन्वायरमेंट रखेंगे हम, बिकॉज ऑलरेडी हम लोगों ने देख चुके हैं, हम लोग देख चुके हैं ना कि क्या चीज़ें कौन कौन सी लाइब्रेरी हमें इंस्टॉल करनी थी। एंड ऑलरेडी दिस इंस्टॉलिंग द लाइब्रेरी एंड क्रिएटिंग द वर्चुअल environment took lot of the time, so I'm not going to do it again. So I in the same environment will work today also. So what I'm going to do, I'm going to share the screen. Just a second. Okay. Oh, Llama index. Just a second, guys. Can you guys see my screen? Just a second, I think. No, not this one. Okay, nice. Now we have, okay. So these are the things we have done yesterday. Okay. Now today we will do some better things also, right? So I'm going to create a new Jupyter notebook. Just a second. Not here, not here, not here, right? So I'll say session 2.ipynb, right? And what I am going to do now, mm, just a second. I'm going to select the kernel, okay? Great. So what I would like to do very first, what I'm going to do, I am also going to, we will need to install the library, right? So what are the libraries do we need to install it? Here are the libraries. So what I'm going to write, I'm also write the same thing. So whoever missed the yesterday class, we are going to use three libraries, Llama Index, Llama Hub, and OpenAI. And yesterday we have created this LLI DXVENV, which is nothing but a virtual environment. Okay. Now, just a second. I think I'm facing some issue in my screen, right? Whatever the screen I'm sharing it. Fine. Okay, it's great now. That's perfect for now. Who is saying Kumar Pritam? Can you just quick review for create the environment because I was missed the yesterday session. Simple. Okay, I am going to write here for create the VENV. Just write Python m VENV. Here will be your VENV name, right? So this is the command which we use in order to create the virtual environment, and command for create the command for activate the virtual environment, activate the VENV. What we are going to do, we will say slash hyphen your VENV name, right? Then we say scripts, then we say activate. So this is the command in order to activate your VENV, right? Yes, sure, Umer. So now our speed definitely will be increased. So I just want to I just want like each and everyone should have a clarity about it, right? Now, what is the next step? You need to set up the you can say API in your OS environment, right? So now what we are going to do, setting up the OpenAI API key in OS environment, right? How you can do that, right? How you can do that? Yesterday we have seen we have two ways in order to perform this operation. Like from two ways we can set up the OpenAI API in the OS environment. One with the help of OS, right? And another way was with the help of OpenAI, right? Now, how we can do with the help of OS? We'll say os dot environ, and here we can just write, anyone know what should we write it? OpenAI API key, right? Then we have a key, so you can write just your key here. Maybe it can be something like that, right? Now, how we can do using the OpenAI? So OpenAI, see, I am very much fast because already all this thing I have explained you yesterday, right? Then we have something called API, right? Uh, Key is equal to, I mean, we are assigning this particular this things, right? So if you're going to execute it, all this API thing is going to be done. So what I'll do it quickly, I will use my API key here, and then I will share the screen again so that because you know that I don't want to share my API with all of you guys, right? Because I don't have a good amount in my account, right? So what I am going to do, I will quickly do my. Okay, great. I hope you can see my screen now once again. Okay. So what I did here, simply I just paste my API key here and I execute the same code. Now I have done I have set up, I have done with the setup of a OpenAI API in my OS environment, right? Sarita, are you going to use the open source also in a future? In tomorrow's session, I have kept open source LLM. I'll show you in tomorrow's session, but not in a very depth. I will just pick a very small model from the Hugging Face and then I'll show to you because I don't have the GPUs and all, right? And if you are going to just think that if any model who have a length of 5 to 10 GB, right? So basically, in order to download all these models, it takes time, right? So just but I will give you the idea how you can do that. And just suppose you are doing all these things, uh, just one or two lines of the code you will have to change it, so you will get it right. So you definitely will. I will cover like how you can use the open source model with the help of Hugging Face and Llama Index, but in tomorrow's session, right? Okay. So I think this is clear to you. Now, quickly, what we are going to do here, I would like to show you what we can do it, right? So now I am saying from llama index dot core, right? I am going to import simple directory reader, right? And vector store index, right? Simple directory reader. This is the data loader, right? It's a data loader. And vector store index, this is the again another class which we use for converting the text into the numbers, right? Basically, in order to create the indexes. Now, what I did, like I have created document. Now, what I am doing here, simple directory reader. Here we had a data, right? I was just copy the path here. Now here, and then what we'll say dot load data. Yeah. So see here. Now we had in a three txt file. If I will print the document, if I will print the document, we can see all these things, right? Or if I will just print only the document, you will see a list who have all the details of the three file, right? Yesterday already we have seen about it all, right? Now what we are going to do it, we have the text. See, the text thing, we have the text. Now the next step is nothing but we have to create the embedding of this text, right? And now how we can do that? We have the vector store index, this library. I will pass the document all this text here, right? And I will say I will store in some index here, right? That's it, guys. And what I am going to do here, I'll just write show progress so that you can see what is going. See here, it is generating the embedding. 100% completed. That's it. Okay. Now we have created the embedding also. Now the next step is nothing but we need to create the query engine, right? So how we can do the query engine? If you will see the index dot, here we have something called as query engine method. With the help of this as query method engine, we can create the query engine. So let's say I am just creating the instance of this particular query engine. So I am giving the name is query engine, right? So now I have created the instance here, guys. Now, with the help of this query engine, I can ask anything. Like I can ask anything. Here, I can say we have something called query, and I can say anything. Give me the list of the candidate. Give me the list of the candidate. So if I will just do that, see, Ashish Rao, Ashish Sinha, Ashutosh Rao, and Ashish Sinha both are our candidates here. Whose resume do we have it, right? Now we were storing it into the answer. Now, if I will print the answer dot response, we'll get only the response. See, we have Ashutosh Rao, Ashish Yadav, Ashish Sinha. So these are the candidates over here, right? So this was the this already we have completed all this thing, right? We have learned all these things. Now what we are going to do it, we will learn a lot of the thing also. Okay. Okay. Any doubt, guys? This is I have just given a quick code review, whatever the things we have done yesterday, right? Any doubt? Any kind of the question till now? Do let me know in the chat, guys, quickly. Mohammed Umair, how the Llama Index and OpenAI AI API are communicating with each other, I'll show you later in the code, okay? Great. So let me show you. Suppose you want to know the similarity score. So, I am talking lots about the similarity thing, right? Similarity score, similarity search. So how you can do that? How you can see that similarity search kind of the things, right? So I'll show you how can you do that. Queries like invoke in LangChain. Yes, Gajral, exactly. Queries like invoke in a LangChain. Okay. Yes, you are right. Okay. Now what I'm going to do, I'm going to use something called p print response, right? Now p print response, with the help of this p print response, we will be able to see all the similarity score as well as what are the similar relevant text we got it, right? So I'll show you, right? So in order to do that, what I'll do, I will import very first pprint response library. How we can do that? From llama index dot core dot, we have something called response here. Then we have pprint utils. See, pprint utils will import uh, p print response here. See, we have a p-print response. Now, what I'll do that, uh, whatever the response answer we are getting it, I'll just put it here, right? Now, p-print response, I'll put the answer, right? So the final response is here, we got it. But how does it got it? How which is the similar sentences, or from, or which sentences it filter out all these three names, right? In order to see that, what I'm going to do there here, I'll simply just set a attribute which is nothing but show sources. I'll say it true. Now see, similarity, we have two sources here. One, the first text is here, even we have a lot of the thing also. The another text is here, right? This text has a similarity around 71%, but this text has a similarity around 74%, right? So what it does, it took, see, we have whole this text, but all this text, this LLM it can't show you, right? So now what it is going to do, it is going to remove all the unnecessary text which is not relevant for you as in a response, and then it is going to show you the answer, right? The exactly the final response here. Okay, let me, let's ask something else also, right? What I'm going to do here, I'll ask, um I will ask, how many year of experience, how many years of experience uh Ashish Yadav have, right? Now we have this answer. Now what I'll do that, I'll just copy this code and I'll print it here, right? Now let's see that. See here, guys. The final response is Ashi Yadav has no specified year of experience mentioned in the provided context, right? See here, one of the context, here it has 76% of the similarity, where it is saying Ashish Sinha, machine learning engineer, this, and blah blah blah. But nobody, I mean, nowhere is mentioned about his experience, right? That is why his it's this the text, the similarity score for this particular text is only 76%. Whereas the text which we are getting it, email ID this, address this, and this, fresh graduate eager to use my knowledge to learn new skill and all. So basically here the, in, in this particular text, it is telling us about the experience of this of the user, right? And that is why here the experience is mentioned. That is why the similarity score is getting 81%, right? Now, due to this reason, since and now see that with the help of the node post processor that I wanted to show you guys. Yeah, somebody of you were asking like what kind of the other task node post processor perform actually here. So see here, we have a fresh graduate. It means that it is yeah, I mean, this Ashish Yadav doesn't have any kind of the experience, but this kind of the text cleaning, pre-processing kind of the thing is done by the node post processor. And after perform this text cleaning and you can say process the this whole text, this node post processor give you the response Ashish Yadav has no specified year of experience mentioned in the provide context information. And then this information is passed to the response synthesizer, and now the response synthesizer is going to display a whole thing, I mean the whole text here, right? So this is how the things work actually, right? So I, this is the main purpose to show you the p-print response actually. Any doubt, guys? See, MK is saying in note 2, experience mentioned is 2 years. But this is about the Ashish Sinha, right? We are talking about Ashish Yadav, guys. So is it clear? Okay, fine. Let's move ahead. Okay. Uh, I hope till here it's clear to you guys. Great. Any doubt, guys? I will wait for 2 minutes only. If you guys have any kind of the question in code in order to understand the code, or in at any point you feel any point problem, you can ask it. Because this is just a very basic thing, right? If it's kind of the base, if you have a problem here, definitely you will face lots of the problem in the future. Yeah, I mean, in next code. Kumar Pritam asking, uh, I have just one small doubt about the data. So we are using the OpenAI. So it means that we are sharing those data to OpenAI server. Yes, exactly. We are doing that. But yeah, now so, see, till now, whatever the model is in the market, I'll say the OpenAI is the most trusted model in terms of the accuracy, right? But now the people have a doubt, like, of course, we have to share the data on the OpenAI server. So now since Microsoft comes with the solution, because at the end now Microsoft has bought the OpenAI, right? Now the OpenAI is the Microsoft product. Now I mean the Microsoft came up with then a solution. They are providing two types of the OpenAI's key. One is normal Open API, the another is Azure OpenAI API key, right? So if you are going to use the Azure Open API key, it means that uh, they whatever that they are going to deploy the model in the Azure server. So you are going to create a server, right, which will be your server, and you will keep your all data inside that server. And now you are going to use the Azure Open API key. So now you are not going to send the data anywhere else. You are going to send the data within your Azure server. All the processing is going to be happened within the Azure server, and you are getting the response. So this is how you can prevent the data security. If you want to use, still you want to use the Open API, I mean Open AI services, right? But if you don't want to use the Open AI or Azure services, just go with the Llama 3. I think this is gonna be very good model. I yesterday I was practicing in a late night, and yeah, the performance whatever the Llama 3 has, uh, it is really outstanding. Even the meta worked on the time complexity also, but this is the later thing. So we have now we I can say that we have a very good open source models in a market also. But yeah, there's another few prerequisites in order to use those model is that uh, we should have minimum 16 GBs of GPU in our system. And most of the you as in a fresher or the person who is just learning the things, most of the people doesn't have a high specs laptop. Because if you are going to buy a laptop who have a 16 GB of RAM, it is going to be cost somewhere around 2.5 lakh, more than that. Okay, so this is a kind of a barrier, we can say. But let's see, in future maybe we can have the technology upgraded, and maybe we can download those model in low specs model also. But for now there's no there's we don't have anything so that we can use the Llama model in the local. For the Llama 2, see, we have a three variant of the Llama 2, 8 billion model. So for the 8 billion model, if you have 6 GB or 8 GB of the GPU, that's good. 8 GB model is going to be somewhere 25 to 30 GB. But the 13 billion, 34, and even 70 billion is going to be around 150, around 120 or 130 GB. So just think that you have 16 GB RAM, let's say. So how you are going to load more than 100 GB of the model in just 16 GB, right? So Ritik, is you saying that can we use a GGML version? I mean, you are talking about the quantized version. So here, the you know whatever the question you will ask to the LLM, right? So the response which you will get it takes lots of the time. Let's say you have asked like just you have asked about this. How many years of the experience Ashi Yadav has it? In order to see within a 1.8 second I got a response. But just think that in order to get the response for this particular question, if you will have to wait for the 10 to 12 minutes, is it worth? And also this is the quantized model, means 16-bit model is going to be converted into the 8-bit. So there we will have to sacrifice with the accuracy, right? So in production in real life we are not going to use the quantized model. Okay. Yes, Suman, you can use the tabular data also. Can we set the behavior of it using prompting? Yes, we can set the Muhammad Umair. We'll see in today's session only. Okay. Llama 2 model you can use on the Collab, but I think Collab also provide only the 15 GB or 16 GB 15 GB of the GPU, or right, and only the 12 GB of the RAM. So what will happen, you can load the Llama 2 model on of 8 billion Llama 2 model, but whenever you are going to ask any question, right, from that Llama 2 model, this the I mean the GPU utilization is going to cross the 16 GB, and as it reaches 15.5 GB utilization, your whole the Google Cloud is going to be crashed. So you can try it, but I have tried it also, but it didn't work for me. Yeah, of course. Even if you maybe you will have to restart the system, and also lots of the problem can be happen, right? Sometimes your whole system got crashed. Fine, guys. Let's come back on the topic. Okay. Yeah, then you would have to recharge it. Who is this? Shubham Wagmer. So yeah, because earlier $18 Open AI were giving you for the practice, but now you would have to recharge. I mean, you would have to pay for that. Okay. So fine, guys. I think that's all. Let's move ahead. We would have to cover a lot of the things in today's session. Okay. Now let's see the retriever. Uh, so guys, what happened? Uh, just a second. Okay. Now what I'm going to do, I am going to explain about retriever, right? Fine. Now, what is retriever here? So, see what is happening here. We are asking a question, right? We are asking a question, and now the our we are this similarity search is going to be happen, and the top similarity search means the top the most of the relevant content we are getting it from that we are getting the solution, right? Now, let's suppose that we want to see the top 5 relevant, right? Till now हमें सिर्फ एक ही रिलेवेंट मिल रहा था, मतलब सिमिलैरिटी सर्च कर रहे थे, और जो भी सबसे ऊपर मिल रहा था, सबसे हाईएस्ट सिमिलैरिटी स्कोर जिसका था, उस वाली चीजों को हम पिक कर ले रहे थे, राइट? बट फॉर नाउ इफ वी वांट टू गेट टॉप 5 सिमिलर थिंग्स, राइट, हाउ वी कैन डू दैट? बिकॉज हियर you see that we are getting only top one similar content, right? But if we want to get top 5, top 4, or you will have to set it that I want to top and similar content from the database. How you can do that? So in that case, you will have to use the retriever, which is nothing but retriever query engine things. You will have to use it. And how we'll have to do that, I'm going to show you, right? Again, in order to do that, you will have to do llama index, now dot core, then dot retriever. What I can do, I'll say import vector index retriever, right? The same thing. Then I'll say from llama index dot core dot, I will say query engine. Here this time we are going to use query engine. Now I'll say import. We have retriever query engine. Okay. Now we have imported it. Now what I am going to do here, I am going to create the retriever here. So I'll say retriever is equal to retriever query engine. Let's see what are the things it takes is, it takes index. So index is nothing but the same thing. Here we have created an index here, guys, right? Somewhere here we have created an index. Index is nothing but the we have created the embeddings of our text, right? Now what I am going to do, I'll say index is equal to, index should be index comma. Now see here, one more thing I'm going to use here. Uh, we have something called similarity. Just a second. We have query engine retriever similar. Let's suppose similarity top k should be 5. Let me see that is it going to work or we are going to get an error. Okay. Index. Just a second. Here is the index. Is there any spelling mistake here? Let me. Okay, okay. I'm really sorry. Very first, we need to use vector index retriever. Okay, yeah. So I think this time it, yeah. So very first, see here, this time, what we are going to do here, we were using the vector store index here, right? So with the help of the vector store index, we will create the index. Now, what we are going to do with the help of vector index retriever, what I am saying, I will give the index here and similarity top k. It means that if I am defining here 5, it shows that I want top 5 relevant content, right? If I will show you, if you will going to remove it by going to set it as a 3, it means that we want the top 3 relevant content from our database for whatever the question we have asked with it. Okay, now if I will execute it, now let's create the query engine. Now in this time, the query engine is going to become with the help of this retriever query engine, right? And here what I will give it, here it will take a retriever. I'll say, yeah, retriever is gonna be this. Okay, yeah, great. Now see here, I'll say query engine, right? Any guy, I have one comment. Okay, query engine, right? So now I am going to explain you all the things once again. We use the retriever when we want top n kind of the content from the database, right? Now, from the top end, how we can do that? With the help of vector index retriever and retriever query engine. Okay. Now, whatever the index we have created with the help of the vector store index, we will give it here. And here in similarity, top k is equal to 3. It means that whatever the number you are going to set it here, that top and similar content we are getting, we will be extract from the database. Okay, I mean vector database, right? Now we will use the query engine here. Okay, now what I am going to do here, I will do query dot, we have again something called query. Now I'll say let's see something first. Let's say Arushi Gupta. Okay, let's see the Arushi Gupta. Uh, she has around 3.5 year of experience as a front-end web developer. Okay. Now I'll ask how many years of the experience Arushi Gupta has, right? Now, what I am going to do here, I'll say answer, right? Now, if I will print the answer, see, it is giving us Arishi Gupta has in a 3.5 year of experience. But what are the top? See, we are getting the top relevant things, right? But I want to know what are the top three relevant texts were there, right? So in that case, what you can do, print response, the same thing you can pass in here, and you can do show source. You can set it as a true. See here, we have total three here. Okay, the first con the context is here, who has 78%, right? The another top context we have is around 76%. Then we have another text which have the similarity around 74%, right? So, but right. So but here, if you will see here, see here we have a dot 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 also. So it means that we have more content here, right? And here, right? Something. So this is how it is going to be shown to you guys. Any question, any doubt, guys? You have it. Who is his mom? If I have I'm in my laptop, but decided Intel you good as it was. Kumar Abhishek, this isn't clear to you. No, no, Ritik Mathu says. Uh, okay, yeah. Okay, so this is also weird. I'm also looking into it. Actually, this text, ideally this text should have a highest similarity score because this text is containing 3.5 year of experience, right? But at the end we are getting the good thing, but this is also right. It's weird, right? I'll have to look into it. That why this particular text is getting only 76% of similarity with respect to this. Okay, I'll look into it. Node IDs total. We want to get the top three. Node ID. Okay, here node ID. See, what is node here? Node is nothing but a the smallest chunks of the whole text, right? So let's suppose that there's 100 lines of the paragraph, and now you are going to create a 10 chunks from that 100 lines of the paragraph. Now how many chunks we will have? We'll have total 10 chunks, right? Now each chunk will, I mean each node will have their unique ID, right? So node 1 have some ID, node 2 have some ID, node 3 has some ID. Similarly here, this particular node has this ID. this node has this chunk has this id, this chunk has this id. Okay, so this is the things. Okay, what is the case Baski? I don't know what do you mean about a case sensitive. What do you want to know about in case sensitive? I didn't get it. Okay, can you please repeat? No issue. Any question, guys? Still here? Do you have like? I hope you got to know why do we use the retriever here. Okay, great. So now we are going to do one more thing. Now see, let's suppose that you are going to ask any question, right? And you want to set it like, okay, if the similarity score is going to be more than 80%, then only I want as a response from the LLM side. So how you can set it, how you can create a you can say threshold value, that if I will if let's suppose, see here we have on a 74% of the similarity also, but you don't want to take any kind of the any response who has less than 80% of the similarity or any number of the similarity. So that kind of the task you can do it with the help of the similarity post processor, right? And what is the similarity post processor? This is the library through which you can set a threshold that if my similarity score is going to be below this number, I don't want to accept this response. Okay, so this kind of the things you can do it with the help of the similarity post processor. Now let's see how we can do that. So let me write here similarity post processor. Okay, now let's see how we can do that. uh I will copy both library here once again. Yes, Gajrail. The same thing we have in a LangChain also. So what we can do it from llama index dot, I'll say core. We have something called post processor, right? I'll say import, and now what I'll do that I'll say similarity post processor, right? Now I want to set it. Let's say I want to say the similarity post processor, the similarity cutoff. Like I don't want any response which have whose similarity is going to be less than 75%, right? Now I have set it, the similarity cutoff is 0.75, right? Which is nothing but a 75%. Now what I'm going to do here, I am saying I'm just giving a name, let's say as processor, right? Now what I'm going to do over here, I'm just copying the same thing here, right? I'm just going to copy the same thing here, but and yeah, the next thing is this query engine, right? This query engine, I'm going to get it from here. But what I'm going to do here, here we have something called node post processor, right? Now here inside a list, what I will do that this the same variable which we have initialized here, I would like to pass it, right? Now if I will execute it, now if I will ask the same question, okay, now in order we need to do the same thing again. Okay, I would like to do the same thing here again, right? Okay, just a second. No, we should not need to do that. So what I'll need to do that? Just a second, my mistake. Let me set it here. Okay, I'll execute it again, once again. Okay, now what I'm going to do, I'll ask the same question once again. Okay, now see, here we have 76, 74, right? But now we have set the threshold that not any single, we don't want any response or any text who have the less than 75% of similarity score, right? So now in that case, if I will do that here, and now if I will do p print response, and here if I will say answer, and now I want to set the show source is true. Now what I'm going to do, see here, we got only two response. One is 78, another similarity score is 76. But the text I didn't get it who had the 74% of the response, right? So is it clear? Is it clear like what is the use of the similarity post processor? Now you there isn't a question in your mind like that uh, where we can use that similarity post processor. What is the use of this similarity post processor in the real life data? So in real life scenario, see, you will be build an application for some organization, right? So what will happen, some of organization wants that I don't want, if give me the response only if you are nine, like you are very much sure and the accuracy is going to be more than 90%. Otherwise, if you have the response, whatever the LLM is going to give it, if the response has the accuracy more than 90%, then only I would like to see that. So in that case, what you are going to do that the similarity cutoff things you can set it the 90%, and then you can build the application. So now you are not getting, you will get only the responses who will which will have the more than 90% of the you can say more than 90% of accuracy. So this is the real world scenario where you can use the similarity post processor. Is it clear, guys? Any doubt till now? Soumya says no. So Soumya, are you not getting it, or is it clear for you? Okay, no doubt. So guys, I can see the 23 people here. So I would like to know like I just want all 23 responses here. Is it like is it clear for everyone or not? Right? Kumar Abhishek says clear, clear, clear. Okay, great, great, guys. That's really great. Nice. Okay, let's go with the another thing. Okay, now very important thing, guys. I'm going to show you. Be with me and please be very focused. What I'm going to show you, I'm going to show persisting index, right? See, you can see here. We are creating the response somewhere. We are creating the index somewhere here. Here we are creating the index. So here it takes, since we had only three documents, that is why it took only 3.4 second, right? But what if you will have on a thousands of records there? Then this the time in order to create this index can goes more than 1 hour, right? Or now let's suppose that by some XYZ reason this kernel is going to be crashed. Then are you going to, in order to create the same indexes, are you going to spend the same time again? Obviously, no, right? So what I am going to do here for now, this index, all these embeddings are stored in my in this variable, right? So if I will off the kernel, if I will shut down the system, definitely I will remove those indexes, right? Now, in order to do all this process, I will again have to create the indexes, then I will do the query and all, right? So this is again a time taking process. Now what I'm going to show you, I'm going to show you, right, how you can save all those indexes in your local system, right? Like we save the files, right? Similarly, I'm going to show you how you can save the indexes in your local system, right? So let me show you. So and also I will show you some best practices in order to do that. Okay, so what I'll say that so very first, in order to do that, in order to save the all those embeddings in the local system, what I want, we I'm going to create a folder, right? I'm going to create a folder where in which you will store all the embeddings. Okay. So let's create the folder very first. So here I'm going to create an folder. Let's say I'm giving the name is storage, right? And inside this storage, I'll create one more folder, and let's say the name of this folder is cache, right? Now, inside this cache, what I'm going to do, I'll create one more folder, which name is, let's say, resume. Any name you can give it, okay? Since I'm explaining you all this thing on the resume data, so that is why I have given the resume. And inside this resume, I would like to create one more folder, let's say sleep. See, guys, this is the standard way, and this is the best practices. If through we can do that, okay, you can just create a storage and you can store in that also. But this isn't comes under the best practices. So that is why I'm doing all this thing, right? Now what I'm going to do, guys, here, see here, persisting index. What I'm going to do again, the same thing we'll do that, okay? So what I'm going to do, I would like to copy the same thing, okay? So what I am going to do, I am going to copy the same thing, and what I will do that, I will paste it here. Okay, so what I am going to do here, the same thing which we have done it already, okay? Now, see here, it took some time since already I had created a indexes, so it didn't take much time. But yeah, if definitely if you will have on a more file, it will take lots of the time. So now what I'm going to do here, what I'll do, I will say index dot. We have something called storage context. Yeah, in from the storage context, we have something called we have something called persist. And now here, what I am going to do, here we have something called persist dir kind of attribute. In this attribute, I will give the location. I mean, I'll give the path of the folder where I would like to store the embeddings. Okay. Now, if I will execute it, guys, now it is executed, and see here, we have there are some files has been created inside this sleep here, right? So now default vector store. Now if you want to see the embeddings, if you want to see the indexes, now you can see that. How you can see that? See here, embedding dict, we have all the number. This is nothing but the numerical representation of all the text which are here. See all the text we have it, its numerical representation is nothing but this. Right. So this is the embeddings. This is the indexes of each text here, right? So I hope till now, any doubt, guys? Do you have it here till now? Please do let me know in the chat. Okay, great. No, all clear. Great. So guys, do let me know how are you feeling till now? Is the session is going to be good for you guys? I am trying to, just trying to clear all the doubt for all of you guys. I don't want to left any single doubt in your mind, right? Great. Okay. What about the others, guys? Are you really getting the things in your mind? Great. Wow, nice. Okay, fine, fine. So okay. Now we have seen how we can store the indexes in our local system, right? Now, what I am going to do, see here. Okay, just a second, guys. Okay. Now, till now, see, we have stored this indexes. Now, we have the file. Now, let's suppose that if I will turn off my system or whatever is happened there, whenever I will restart it, I have the embeddings also, right? Now I will not have to spend much more time in order to create those indexes, right? Suppose I while creating this indexes, it took around 1.5 hour. But and next time when I will commit, I'll not have to spend 1.5 hour, 2 hour in order to create the indexes. I will read the same indexes from here. Now this is the point how we can do that, how we can read the indexes from the local disk, right? Right. So now let's see how we can read all these indexes from the local disk. A local disk, okay, which we have stored in local disk. So I'll giving the command for reading the index from the disk. We use something called, we have storage context. Storage context library, and we have something called load index from storage, right? Okay, now how we can do that? Again, from the llama index, what I will do, from the llama index, I will llama index dot core, what I'll do that I will import storage context and something we have called load index from storage. Yeah. So now these two things I have done it. Now what I am going to do, I will say storage context dot uh, uh from defaults. I will give the path, nothing but the same path where the actually the embeddings are, right? So our embeddings are stored here, right? So here are our embeddings. So I will copy the path here. I will give the location of the path here. So eh, wherever your embeddings are stored here, you will give the path of a folder in which you have stored your embeddings. Okay. Now what I'll do that, since again you can do one thing, you can just store it in some variable. So what I'm going to do, I will say this is our storage context, right? Now I'll say index is nothing but load from storage, and here load from storage, then what I'll do that inside this I'll give the storage context. That's it, right? Now I am saying that that's it. It means that if you will run it here, in this case, all the indexes we read it from here, right? Any doubt, guys, in order to understand the code? Any kind of the doubt do you have it here? Whatever the code we are learning it, if the syntax, if you are not getting it, if any kind of the question, guys, do you have it? Any kind of the misunderstanding do you have it? You can ask it to me, okay? Is the code clear to you? Code are very easy in data science, AI, ML things, right? It is going to be very easy, right? Okay, great. I can see the 23 people here. I would like to hear the from all of the 23, like whether is it clear or not clear. Please do let me in the know chat. Okay. I want the response from everyone, whether it's clear or not clear. Please be active, guys, here, right? Okay, great. Okay, Gajral is Gajarla is saying I would like to repeat. Yeah, I'll do that. I'll repeat it once again. Not an issue. Definitely, I'll repeat it. Okay, not an issue. So see here what I was doing it. So till now we were creating the index, right? Is nothing but we were creating the embeddings of the text. But we were not storing it anywhere, right? We were not locally storing it on our in disk, right? We were just storing it in our variable. But so let's suppose that by somehow you are going to your system is got crashed, right? And now you will come again and now you will see that okay, I will have to create the embeddings again. And last time when I created the embedding, it took around 1 hour, 2 or 3 hour, right? Now you would have to spend the same time. But what if you will store the same embedding in your local system? Now the same thing what I am going to do here, very first very first, what I'm going to do here, I have created a folder where I want to store the embeddings. Now, with the help of the simple, with the help of this storage context dot persist method, I have given the path of the folder where I want to store the embeddings, right? If you will execute this particular thing, this particular code, you will see that all the embedding has been created and stored in the folder which path you have given here, right? Now you have created and you have stored the embeddings in your local system. Now you will have, if you have stored it, you have to read it also from there, right? Now in order to read it from there, what you would need to do is that you need a storage context method and load index from storage method. So now in storage context, by using this, by from default, you will give the path of the folder where your all the embeddings are stored. Now the same storage context, you will give it here, your all the embeddings which you have in that folder is going to be loaded in this particular variable, right? I hope this is clear for you guys. Is a Kumar Pritam is asking, is it called a vector database? See, this is the vector database. See, listen carefully first. This is the vector database. What, but if the same thing, exactly the same thing, if we will store on some cloud services, right? Let's say Astra DB, we have Pinecone. So these are the database, and the same kind of the vector is going to be stored on that services. I mean Pinecone, Chroma DB, Space, in that kind of the services. Then we will say that this is the vector database. And here in this case, this whole folder, this complete folder is going to act as in a vector database. What is the use of creating this? For example, if we have local database like phase already. Yeah, you can use the phase also, but did I explain you the concept of phase? No. So once I will explain you the concept of phase, then we definitely you will get to know what is PineDB. Pinecone is. Do you know about SQL? Do you know about MongoDB? Do you know about any SQL database, right? So these are database in which you store the information, right? Similarly, Pinecone is also a kind of database in which you store the embeddings. Gajjar is saying that how can you use this in real time? In real time is like suppose so basically, see, whenever you will work for any project, any client, so all this thing, all this folder, you are not going to do it in your local, right? All this folder you will be transfer, and all this folder along with the code you are going to be transfer on the AWS or Azure or any cloud services. And now you are going to execute, you will execute the code on the cloud. So this is, I'm talking about a deployment. So when you will do that, so this folder will be in the cloud and this code will be also in the cloud in the same folder, right? So this is how you can use it. So I don't want to talk about the DevOps thing and deployment things. I don't want to confuse it here. But yeah, do let me know whatever the thing in this here. Is it clear for you? Whoever asked about to repeat this thing once again. Okay, great. Nice. Now guys, yesterday we were talking about something called token limit, token size, context window, lot of the thing, right? So this is all about like the token should not exceed, right? Now the question comes that how we can count the token, right? So I'll tell you how you can count the token. So the next I'm going to tell you is that how to count tokens used when creating and querying Llama index, right? So, okay. Now, in this case, what I'm going to do, guys, I am going to use a services called tick token. So, okay. So, what is tick token? I'll let you know. Just a second. What are the things are left? Okay. I have three, four things also. So what I'm going to do, I will import an library called tick token, right? Now you guys might be asked, like, what is the tick token? Okay, so tick token is a open source tool, or you can say this is an open source library provided by the OpenAI. So basically it is used to tokenize the whole text, right? So now you are saying that this I am all again and again saying that we have a whole paragraph and now we are going to converting in the smaller chunk. Now, this smaller chunk is nothing but a token. But how exactly we are doing it? We are doing it with the help of the tick token library. So internally, it is happening here. So if you remember, we have installed only three library. One is Llama Index, Llama Hub, and OpenAI. But if I will show you the all the library here, so internally we have the tick token also. So very first, if I will just activate my virtual environment. So just quickly, I would like to activate it. Okay, just a second. We are using the PowerShell, but I want to use command prompt. Okay. Now the same thing I would like to do. Okay, we are in this virtual environment. So if I will just quickly show the pip list, right? Remember, I didn't install anything. We installed only the three library, Llama Index, Llama Hub, and OpenAI. But if you will see, tick token is already here, right? Why? Because it is the supported library. And what is the supported library? Already I have explained you yesterday. What is the task? What is the usage of this token? This library is responsible for tokenize the whole context. Okay. I hope this is clear to you guys. Right? Is it clear? What is TikTok and what is the uses of TikTok, guys? Do let me know here. Okay, great. Great, guys. It's really great to know. So now I have imported a TikTok in. Now what I am going to do, I will use, uh, I'll say from, just a second. Mm, hmm, okay. Okay. Three things are left. So let's quickly cover all these three topics and then we will be done with our agenda for today's session. Okay. So let's do that. Now, what I'm going to do, I'll say llama index dot core. I would like to import service context and then we have something called from llama index dot core. I will say import and I'll say callback manager. Something we have callback manager also we have it, right? So I think here we have callback callbacks. I'll import callback manager and I'd like to import something called token counting handler. Yeah. So these are the things I would like to import it, right? Now what I'm going to do over here, I would like to say token, uh, I'm just creating a variable named token counter. Yeah, token counter. What I'm going to do now, I'll create the instances of token counting handler. Here, what I'm going to do, here we have something called tokenizer. Now here I am going to use tick token dot we have something called encoding for model, right? Encode this method, and now here I'm going to use the model name, which model I want to use it, right? So this is the model name I'm using it. So I am using text embedding ada and I think I am using this pro. So okay, so if you guys have any kind of the confusion that this what is this text embedding ADA 0002, it is also an LLM, and just type this thing on Google, you will get all the things, right? And already I have explained to all of you a lot of the things so that whatever the things you will read it there, definitely you will get it. Okay. Now I'll say encode. Not here. Even it should be after this. Now I'll say encode. Okay. Now this is the first parameter which I have passed, and now verbose I am setting the true just in order to see the progress. Okay. Now token counter is done. Now I am saying callback manager. Callback manager. I'm saying callback manager, and it should be you can say callback manager. Here I'm just passing the token counter as in a list. So I'm just passing the token counter as in a list. Okay. Now you will use, I'll create a service context. I will create the instances of the service context. Now I am going to use service context dot from default. Already we have used that. And the callback manager should be your this callback manager. All right. And that's all. We have done it. Now let's execute it. Okay, now we are ready to go. Now what we will do that we will just create the index once again. And now index will be vector store index, right? Now here what we will pass the document, which is nothing but in which we have the text of all the files. Now we want to set the show progress is true, which already we have seen it. The only thing I'm going to pass is nothing but service context is nothing but a service context. Yeah, the same thing. Now if I will execute it, it is generating the embedding. See, embedding token A, we have total 2767. This is the total embeddings which we have here. So see guys, I think you can see now. Let's do the query. Okay, here let's see that whether are we getting the query here or not, the token things or not. So what I'm going to do here, I will say query engine is equal to index dot uh, as a query engine. Now I want to use, okay, let's see, and then query engine dot query. Now whatever the thing you can ask is, ask what is the email ID of the, what is the email ID of, let's say, Ashish Yadav. If you will do this, see, the response which we are getting here, Ashish Yadav at gmail.com, and the embedding token uses total 12 tokens. I mean, this is the token size which we got as in a response. So this the token, we are using total 12 token in order to get this response. Is it clear, guys? Any doubt? I think this was the question for a lot of the you. How will we get the, how will know that what is the embedding size, what is the token size, right? So this, through this matter, that time I don't want to, I don't wanted to show you like why how we can see that, because I want to show you all this thing by the practical, right? I don't want to show you anything by by just in a theoretical way, right? We can save is token if we use Hugging Face embedding free model for creating. Yeah, yeah, you can use Muhammad. What about the other guys? Is it clear for everyone? Okay, guys, just one thing I would like to do one thing. I'm just sharing a link for today's session review. Right. This is the Google form. I'm just sharing in the chat. Uh, Please fill this form, right? Just give your honor, whatever whatever you feel about this session, you can do that. Okay. Please, guys, please click on the link and do let me know that I think everyone is able to access this Google form. Do let me know if anyone can't access this. Okay, great. Okay, didn't receive. Shoaib, I have. Okay, okay, just a second. Just a second. I'll save it. Uh, just a second, everyone. No, I think I have shared again. I think you guys have received now. Please click on the link and do let me know that आप सबको मिल गया link कि नहीं. And please click on the link and do let me know कि that are you able to access that form or not, so that we uh, if okay. No, no, little bit things are left. Okay. So basically we have two things are left. Prompt template. How can we create the prompt? And how can we, how can we use the LLM with the Llama index? Mohan Yadav is can't access it. What about the other? Uh, Please do let me know. Sufal, are you there? Like, I think a lot of the people can't access the Google today's session 2 feedback form, right? Safal, are you there? Guys, just yes, yes. Give me 1 second. Give me 1 second, please. Hmm, just a second. I am just trying to solve this issue. Hmm. Just wait for 2 minutes, guys. Okay. Be in the session. Guys, please be in the meeting, okay? The backend team is looking into it, that why this is happening here, right? So, okay. Meanwhile, let's continue our session. Or we have 2 points. Well, so till now, guys, just give your honest feedback. Like, what are you feeling about this session, right? Whatever the things we have covered till now, from the beginning to end, any doubt, any kind of the problem are you facing in the code, in order to understand the syntax, in order to understand the concept, anything, if you are facing any issue there at any point, feel free to ask it, right? Don't hesitate it. और यहाँ पे कोई किसी का रिश्तेदार है ही नहीं, तो फिर शर्माना क्या, राइट? तो किसी भी टाइप का कोई भी क्वेश्चन है ना, यू कैन आस्क इट हियर. Okay, how to remember these many libraries? Okay, it we can. I'll show you how you can remember it. Okay, I would like to share my Chrome. Can you? Okay, I'm sharing a Chrome here. Can you see the this Google Chrome? Can you see, guys? Okay, you can see the Google Chrome, right? Now, let's say you want to use. Just go to the Llama index documentation, right? Click it here. Okay, just a second, guys. Okay, just a second. Okay, see here, starter example, tutorials are there. See here, we have the code here, right? All the things are here, right? And suppose that see here, the same thing I have done it, right? Vector store, simple directory reader, I load the data, right? And then I have done all these things, start tools. A lot of the things are there. See, core setting, chroma vector store, vector store index. I want to use a different LLM. You can use it, right? I want to use a different response method. Here is there. I want to stream the response back. Everything you will get it on the documentation, just explore it. I also am not I don't, since, see, I am working on the same thing since last 2 years, so that everything is memorized in my mind. But when I was working it, I also, there's no need to keep memorize all the things library in your mind, right? Just you should have to keep one thing in your mind, that let's say which library you will have to use for which purpose, right? So for example, vector store index library you will have to use for, in order to create the indexing. So this thing you will have to keep in your mind, or whether you are not getting it, so just type on the Google. Let's say okay, let's say, how can we create the indexing of the text using Llama index. See, everything you will get it. And Python. If you know how to Google, you are a developer actually. Right? See here, indexing and embedding. What is index? Data structure, compose, object, enable query, everything you will get it, right? You are getting the code also. See, you are getting the code also. See, here you are getting the code also. Are you getting it? Loading and ingestion. Everything, guys. Storing. How you can store. See, this method I told you, right? This method I told you. Just now I taught you, right? Everything is here. Querying, how you can query the thing from the data. See here, this method already have told you, retriever, response synthesizer, I have told you, explain you, right? Similarity post processor, I have explained you, right? Similarity top k means top 10. So if uh, I know that you guys didn't explore this Llama index documentation, but definitely at the end of this session, I mean, at the end of this course, when you are going to explore this Llama index documentation, you will found that in just within a 5 days, I have explained you all the things in the Llama index, right? And really, if you will focus in a good way, definitely you will not find any issues in order to write a code or in order to do anything, right? For what about the interview? See, this is very important. Like I told you, na, that you should know that which library use for the which purpose, right? But in the interview, if you ask like how will you create or how you will now the how you can create the indexes. So just told them the concept. What is the indexes? It is the embedding. And if they will ask you which library you will have to use it, see that you can see that there are many libraries are available. I would have to check the documentation because I understand the code. I do not memorize the things in my mind. It's simple, guys, right? You should know how to answer to the interviewer और इतने explain जब करो ना चीजों को तो to be very confident. I am saying to be very confident. I am not saying to be very overconfident, right? Explain इस तरीके से करो ना कि सामने वाला confuse हो जाए. Okay, ऐसा भी होता है क्या? मतलब देयर इज समथिंग लाइक दैट। मैं अपना पर्सनल एक्सपीरियंस बता रहा हूँ। मैं मैंने क्या किया था, मेरे से जब मैं अपनी दूसरी कंपनी में इंटरव्यू देने के लिए बैठा था, तो उस बंदे ने मेरे से सपोर्ट वेक्टर मशीन का वो पूछ लिया था, मैथमेटिकल इंट्यूशन। अब मैंने सपोर्ट वेक्टर क्लासिफिकेशन, उसने रिग्रेशन का पूछा, मैंने क्लासिफिकेशन का मतलब इतने अच्छे तरीके से उसको बताया और इतने कॉन्फिडेंस के साथ बताया कि वो कंफ्यूज हो गया कि मैंने पूछा क्लासिफिकेशन था कि रिग्रेशन, राइट? सो बट हाँ, ऐसा नहीं है कि आप इतने कॉन्फिडेंस से बता रहे हो तो गलत चीज़ ही बताने लगो। यू विल हैव टू बी ऑन द ट्रैक। थोड़ी बहुत चीज़ें इधर-उधर होती हैं तो दैट्स ओके। ओके गाइज़, जस्ट अ सेकंड, आई विल शेयर यू द अनदर लिंक। जस्ट अ सेकंड, ओके? जस्ट अ सेकंड। प्लीज़ गाइज़, व्हाट आई एम गोइंग टू डू, आई एम शेयरिंग यू द अनदर लिंक ऑफ द the feedback form link of this session. Please click on that thing and do let me know that is it accessible for everyone or not. Is it accessible for everyone? Please do let me know, guys. Then we will wrap up the session. Okay, we'll learn all a lot of the things by tomorrow. Is it a Zoom link? Okay. No, no, no. Okay, just a second. I don't think that it's a Zoom. Okay, I think I have sent you the Zoom link. Okay, my mind has gone. Just a second. Try to hit on this link, please. It's now okay. What about the other guys? If it's possible to share some interview question related to Llama Index in the last session and also some GenAI perspective. I'll share definitely. You'll not have to ask about it. It's very genuine that whatever the it's my funda, like whatever the things I teach. In the last, I also explain the most important interview questions and how you will have to give the answer for that, right? Uh, so guys, this is all for today's session, right? We have seen a lot of the things and all the theoretical things has done. By tomorrow maximum, we will complete all this Llama index. So please do not miss the tomorrow session is going to be very important. So what we will cover tomorrow, we will complete all the things in the Llama index by tomorrow only, right? And I will try it. So what I did today, today I was writing the code in front of you, but by tomorrow what I'll do that already, I will write the code already. Now I'll explain you step by step so that this will increase the speed also. And because we have only 5 days, and within the 5 days we'll have to cover it. And the next, I mean the last 4 and 5 days, I will explain you the project, I will cover the project. Okay, so at the end of this course you guys will have a very handsome project in your hand and a good knowledge of the Llama index, right? And guys, please do not forget to give the rating on the website also. Okay, so you can give the rating on the website in the course. So you can do that there also, right? So that's all about the today's session, guys. Thank you so much. And if anything else do you want to ask it, you can do that. See, Baski is saying that is a project fit to the real-time situation. If you will speak to the interviewer that this project you have done in your previous company, they will immediately going to be trust on your talk, right? Just because the project which I'm going to show you, these are not going to be the demo project. These are going to be the real, like you can say it was a live project. Like I have built the same system for my client. The same thing I will explain you here, but the data which I will use it, that will be the dummy. So if you are going to use it on the real world scenario, you can just change the data sources. Everything will be, great. Of course, Devasis, I will show you the open source example tomorrow. Yes, Mohammed Umair, tomorrow we'll cover the agents also, or React agent and all. No, there is no free limit in OpenAPI. Of course, it was earlier, right, in the early stage of the OpenAI, but now they are very rich. They don't want to give any you know, free amount to anyone for practice. Thank you, Abhishek. Now you guys can leave the session, please. Have a good day and good night. Good night, Shavani. Good night, guys. Thank you, guys. I'm just leaving the meeting. Okay, I'm just बंद कर रहा हूँ मैं. Thank you, Sarita.